Welcome back. In this video, I want to tell you about what we do to keep track of what we are doing. And we use a version control system called Git. So why do we do it? Basically, and it is because we want to be able to go back to other versions that are better fitted for what we do. Yeah, sometimes it can happen that we write a code and something goes awry, kind of, so we just want to go to that version. Yeah, because we can work better in collaborations by working in the same document or different aspects of the document. Then it's better to use a Git system for it. And because we definitely don't want to keep track in our minds which version is the one that it was really good, like version 4 or 5, and it starts to get confusing at that point. So I think many of you have had a document where you create your document and you send it to your supervisor or prof or collaborator, and you write revised by blah blah, and then second revision and third revision, and yeah, it starts to get confusing. So it's much better to have the Git version or the Git system to track the changes. What you need? First, you need to make sure that you have Git. If you do not have it, you need to install it and have the newest version. Then you will go to your project directory, which we created in the last video, and you in the upper part, in the main folder or directory of your project, you initialize Git. And what does it mean? We tell Git then to start to follow all changes that you have or you do in your project. Now, how do you initialize Git? And you just go in your project directory. In this case, I call my project my great project, and I do it as always. I do my Git, which is calling the Git program, and I tell it to initialize with init. What is it going to happen? The Git will create a new directory that will appear called .git. Now, you might not be able to see it because any file that is .git is invisible, kind of like hidden. But if you put your file explorer or you do a certain trick on your command line, you can see that it was created. I'll show you when I do the demo. That will be the last video of this series. Good. So when we are initializing, it's keeping track. What does it mean to keep track? And this is what Git is doing, and that's why it's so effective with the storage of data. Why? Because usually if we will have different versions of a file, you will have like a file that is 1 megabyte, version 1, version 2, 1.2 megabytes, version 3, blah blah, and so on and so forth. And at the end you will have like 20 megabytes of information of things that are really not necessary because it's a copy of the other ones. So you're not being very effective with your storage. And what Git allows is it has your first version, and then you have some changes. Those changes you put it in your document, but those changes are being tracked. So everybody, like, there is a way where Git knows those changes were added, and the same with the next one. So you always have your latest version, but you keep track of all the changes that were done in case that you need to go back to a previous version. By initializing, you start to track all changes in all documents that are non-binary. That means text and numerical files. Some of the extensions that you might know are CSV files, TXT, MD for Markdown, TSV, FASTA, and so on and so forth. We have installed Git. We know that we have the newest version. You initialize the Git in your directory. Now you have to tell Git what files are not necessary to track that might be in your project. And why? Why would you choose not to track any file? And it's because or they are too big, and or they don't change at all. Like for example, in data raw directory, it never should change, yeah, and you don't want to keep that because there is no need. You want to keep track is what you are doing in the other files. And it could be as well because there are binary or images which their changes cannot be tracked properly by Git. So how do you choose what to track? The first thing is you need to create a text file with the name .gitignore. So it's going to be a hidden file, yeah, and inside that file you need to write the extension of the files that you don't want to track, or the directory that you don't want to track. We talk about that because they don't change, like the raw data, or because they are not trackable binary files. This is an example of what I will write in a gitignore file. I have all the binary files that I don't want to follow, like extension doc or PDF. My raw data folder I don't want to track, and any compressed files that zip or tar can happen in the manuscript if you're using LaTeX, and any graphic files like PNG or TIFF. Sometimes I think I do keep track of the SVG, which are vector files, but I'm not 100% sure if those are trackable or not, but I just keep them there. They are very small, so I don't saturate the system. We already told what to track. Now it's time to track your changes in your computer, and this is only for your own computer, okay? So you have your document and you have made some changes, then you use the command git add, which is going to put the documents that you tell it to follow, or to put in the staging area. And in that staging area you put all the files that you modified and that you want to keep in a group. And then once they are all there, you put okay, now is git commit, meaning in the git commit there will be added a message, and that message will kind of like correlate with the changes that you are 100% sure you want to introduce in your repository, yeah, or in your document. Now let's go a little bit more direct. So when I have a project, then I usually use the command git add dot. This will add all changes inside all the modified files to the staging area, and we'll choose, of course, all those that are not listed in the gitignore. And then I will have, once they are all there, I do usually, the first one is usually git commit, and then I tell that the message that is going to be associated with that commit is called initial commit. And then it will add all the stage changes to the local repository with a message called initial commit, so I can find that again. So now your changes are being tracked, and that means that if I mess up something, I can go back to previous version, or if I want to try something new, some other analysis or some other code, I can create a branch with the new trial and not mess up the original version, but give it a try in the new branch. And then if I find, oh, that was a good decision or it's working now, then I can merge the branch to my original version, and the original version has not been damaged or anything. What is the learning potential for advanced users of Git? So you can, the next step will be to create a remote repository in GitLab. The University of Munich, all the universities in Munich area, they have access to a GitLab and a repository, which is kind of like a cloud, and for your Git projects. And then you can synchronize your projects with your remote repository, and then you can start to collaborate, because other people will have access if you give them access to your repository, and start to improve your code or work together. Good. So if you want to go deeper into the Git, I really recommend you from Software Carpentry, the Git for Novice material. And if you are on RStudio user, there is a excellent documentation in kind of like an introduction for beginners into RStudio Git GitHub, done by Malika Ile from the Open Science Center of the LMU. It's a really nice material, and I really recommend you to go over it. So in general, what do we do in the lab? I've told you that we work with virtual environments managed by Conda. We keep a node directory structure so that allows for reproducibility, and we keep track of all changes to make it transparent and easy for collaborative work with other labs, other groups, other members of the group. All this is what we're doing in the lab to guarantee reproducibility and being able to share our data and data analysis with the community in general. So if you have any ideas, any questions, write it in the comments. And the next video will be a demo video of exactly how I go over all this in the command line. Okay, so see you next time. Bye bye.